In this video, we're going to cover how to solve one-step inequalities. I made another video reviewing the basics of inequalities. The link for that's going to come up right now, as well as at the end of this video. You can check out that if you like. But in this video, we're going to solve equations that look like this. So x plus 3 is greater than 5. Now we want to solve and graph this. So our inequality sign here is greater than. We read our inequality the same way we read our equation from left to right. We're going to solve this like we'd solve a regular equation. We want to get the x by itself. We're going to use inverse operation. So we're adding the 3. We're going to subtract 3. Inverse of addition is subtraction. Subtract 3 on the left and the right side. 3's cancel out. So we get x is greater than 2. Now we can graph this solution on our number line. We're going to have 2 here. We have just greater than, not greater than or equal to, so we want an open circle at 2. Our greater values are to the right, lesser values are to the left, and since x is greater than 2, we're going to shade to the right. Now to check this, we can pick a value in our solution set. So a value greater than 2, well, we've got 3, 4, and any value greater than 2, I'm going to choose 3 to check. So to check this, we can put the 3 in for x here. So we'll have 3 plus 3 is greater than 5, and we get 6 is greater than 5, which is a true statement, so our solution in our graph checks. Let's do a multiplication equation. So what if we have negative 2x is less than 10? So to solve this, we want to get the x by itself, so let's divide by negative 2 and negative 2. Negative 2 and negative 2 cancel out, so we get x on the left side, and 10 divided by negative 2 is going to give us negative 5. Whenever we multiply or divide by a negative number, we have to flip the inequality. And that's an important thing that you have to remember. Whenever we multiply or divide by a negative number, we need to flip the inequality. So instead of less than here, I want to flip this to greater than, so we get x is greater than negative 5. So now when we graph this, we can have negative 5 here. We want an open circle. Larger values are to the right, smaller values are to the left. If x is greater than, we're going to shade to the right. Now our possible values in our greater than solution set, and we've got negative 4, negative 3 here. So we could try that negative 4 in for x. So I'll do that all both to the sides. So negative 2 times negative 4 is less than 10. Negative 2 times negative 4, when we multiply negative times a negative, we're going to get a positive. So we get 8 is less than 10, which is a true statement, so our solution checks. Let's do one more practice problem before we get into our examples. So what if we have y divided by negative 2 is greater than or equal to negative 3. So now we're dividing by negative 2. We want to get the y by itself. So to undo dividing by negative 2, we have to multiply by negative 2 and multiply by negative 2. The negative 2 and negative 2 cancel out on the left. And negative 3 times negative 2 gives us positive 6. But we remember when we multiply or divide by a negative, we have to flip our inequality. So instead of greater than or equal to, we get less than or equal to. So our solution here, y is less than or equal to 6. Now when we graph this, we'll have 6. Now we have less than or equal to, so we want a closed circle at the 6. Larger values are to the right, smaller values are to the left. Y is less than 6, so we'll shade to the left. And what values do we have that are less than 6? Well, we've got 5, 4, 3, 2. So now we need to check our solution and our possible values that we have here, 2, 3, 4, 5, and 6. Remember, 6 is included in our solution set because our value for y is less than or equal to 6. Whatever value we choose, we're going to substitute in for y, and it's going to be divided by negative 2. So we want to pick a value that we can easily divide by negative 2. So let's go with an even value. I'm going to go with 4. Let's put that 4 in for y. So I'll check that off to the side. So we can have 4 divided by negative 2 is greater than or equal to negative 3. 4 divided by negative 2 is negative 2, which is greater than or equal to negative 3, which is a true statement. Now we could use any of the values here to check our solution. Just to show you this, I'm going to choose 6. If I put 6 in for y, 6 divided by negative 2 is greater than or equal to negative 3, and I get negative 3 is greater than or equal to negative 3, which is another true statement. All right, so let's do a few more examples solving one-step inequalities. For number 1, we've got x minus 9 is greater than 14. So let's get that x by itself. I'm going to add 9 and add 9 to both sides. I get x is greater than 25. Let's check this. So I'm going to graph that out. I've got 25 here, Larger values to the left, smaller values to the right. Want an open circle at 25, x is greater than 25, so we're going to shade to the right. Want a value larger than 25 to check in our solution, so we could just use 26. So I want to put that 26 in for x. So we have 26 minus 9 is greater than 14. And we get 15 is greater than 14, which is a true statement. So our solution in our graph checks. Number 2, 15 is less than or equal to 3 plus x. Let's subtract 3 and 3 from both sides. I get 12 is less than or equal to x as my solution. So now let's graph this out. We'll get 12, close circle, larger values to the right, smaller values to the left. So 12 is less than or equal to x. We can flip this inequality, put the x on the left side, and just flip the inequality along with it. Sometimes it's easier to read if the variable is on the left side. So now x is greater than or equal to 12. So if x is greater than or equal to 12, we know we're shading to the right. We know where our variable is in relationship to our number. So let's pick a value to check. We've got 12 here. Since 12 is included in the solution set greater than or equal to, we could just check that value 12 in our inequality. So we'll get 15 is less than or equal to 3 plus 12. And then 15 is less than or equal to 15, which is a true statement. And let's do 2 more examples. Number 3, we've got negative 5y is less than 25. I'm going to divide by negative 5, divide by negative 5. Negative 5 cancels out, so we get y. And then negative 5 on the right side, but we're dividing by a negative here, so we have to flip that inequality. So instead of less than, we're going to get greater than. Let's graph this out. We want negative 5 in an open circle. Y is greater than, so we're going to shade to the right. Our possible values, we've got negative 4, negative 3, negative 2. If we keep going here, we know we've got negative 1 and 0. If we could use 0 to check, that's always going to be the easiest value to check. So I'm going to try 0 in here, check 0 in here. So we're going to get negative 5 times 0 is less than 25. And we're going to get 0 is less than 25, which is a true statement. And number 4, we've got negative y over 3 is greater than or equal to negative 9. So we want to get the y by itself. Let's multiply by negative 3 and negative 3 on the left and the right side. So the negative 3 and negative 3 cancels out on the left. So we get y on the left side. And then 9 times negative 3 is going to give us 27. But now we're multiplying by a negative, so this inequality has to flip. Instead of greater than or equal to, it's going to become less than or equal to. So let's graph this. I'll get 27. I want a closed circle. Larger values to the right, smaller values to the left. Y is less than or equal to 27, so I'm going to shade to the left. I want my smaller values. So let's check a couple values here. We know that since it's less than or equal to, we can use that 27. Check the 27 in for y. So let's do that. We have 27 over 3 is greater than or equal to negative 9. And we're going to get negative 9 is greater than or equal to negative 9, which is true. And our values here are values less than 27. We've got 26, 25, 24. So if we want to choose one of these 3 values, well, which value would be a good choice? Let me clean this up a little bit. Which one of these would be a good choice to substitute in for y here, 24, 25, or 26? Well, the good choice would be 24 because 24 is divisible by 3. And if we had to do any more complex math here, it'd be easier to not have to work with decimals. You want a number that's easily divisible by that denominator. All right, so let's do negative 24 divided by 3 is greater than or equal to negative 9. And we're going to get negative 8 is greater than or equal to negative 9, which is a true statement. So this video was on solving and checking one-step inequalities. I hope this video helped you understand this concept. You can check out the link for the video that's coming up right now on basic properties of inequalities. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.